Hello and welcome. Today we are continuing with our discussion on aromatic reactions, where we are looking at addition to ortho, para, and meta positions. So we are looking at ortho, para, and meta directors. And this video is presented to you by Science Visualized. Now, if we look at aromatic rings, for example, benzene ring, if that ring has a substituent at this position, I'll call it S, then that substituent can fall into any of these categories. If that substituent is NO2, then that's a weak director, and it's going to favor meta position. So it will be a meta director. So that means it will direct the new group to go to the meta position. Remember, position 1, 2, 3 is the meta position. You have two meta positions, so there. So NO2 is a meta director. Actually, all these groups here are meta directors. So NO2, sulfonic acid, and sulfonic acid is SO3H. Ketones, carboxylic acid, esters, and aldehydes. So that's hydrogen there. Aldehydes. All those are meta directors. That means they deactivate the ring. So meta directors, they deactivate the ring. On the other hand, we have substituents that activate the ring. That means they pump electrons into the ring. They increase the electron density of the ring and makes the benzene ring more nucleophilic. So they increase the nucleophilic character or nucleophilicity of the ring. So these are very strong directors. In fact, as you go to the right, the farther you go to the right, the stronger the director. So for example, NH2 is much stronger than OH, which is much stronger than just an alkyl group. So the farthest to the right will be the strongest. It increases to the right. If you have a situation where you have two directors in competition, so for example, OH and NH2, because NH2 is stronger, then NH2 will win. If you have a situation where a ring deactivator, like say NO2 is in competition with say OR, then OR will win because it's further to the right, so that becomes a stronger director. Now there's another unique group in the middle, the halogens. Iodine, bromine, chlorine, fluorine. These are actually ring deactivators, but they favor ortho-para position. So they're just like the ring activators, which favor ortho-para position. So that means if you have a ring activator, I'll just use A here instead of S, then that will favor addition to the ortho position, and there are two ortho positions, and also to the para position. Remember, the 1,4 relationship is going to be para. So the halogens favor ortho-para addition, but at the same time they're ring deactivators. So they're generally weaker than the other ring activators. So now let's apply this. If you have a substituent, and that substituent is a ring deactivator, like say NO2, then that's going to favor the new group going to meta position. So ring deactivator favors addition to meta position. And because we are using Br2 and FeBr3, so that means we end up adding bromine. So bromine adds to the meta position, and that will be the product. In this case, addition to either that meta position or this meta position gives the same product. So we just show one example. If you have another situation where you have a group, but this group now is a ring activator, like say NH2, then that's going to be an ortho, and those are two ortho positions, so ortho-para director, meaning that Br2 with FeBr3 will add Br to the ortho and para position, so you end up with one product, Br added to the ortho position, and another product, Br added to the para position. Next, what happens if you have more than one substituent on the benzene ring? In this case, we have NO2, which is a meta director, So that means NO2 will direct the new group to go to position that's meta with respect to that NO2 position. So if that's position number 1, and then 2, and then its 3 position, that would be the meta position. And then you still have another meta position right there. Meta position. So NO2 is directing the new group to go to those 2 positions. What about the OH? We know that the OH is an ortho para director. So that means it's going to direct the group to go to a position that's ortho to it. So that means it is agreeing with NO2. So that position is highly favored because both of those 2 groups agree. And then also para position. And it turns out that the para position actually agrees with this other meta with respect to NO2. So you end up adding the 2 groups to those 2 positions, right there and there. We are using Br2 and FeBr3. That means we are adding Br to this position. So that becomes Br plus Br to this other position. So that becomes Br. And those are the 2 products. Next, we see that we still have the same 2 groups, NO2 and OH, but now they are at different positions on the ring. The NO2, we know that's a meta director, so meta to it, but this other meta position cannot add there because it already has an OH group, so nothing happens there. So it only favors one meta position. And then the OH is an ortho para director, so one possibility is there, but this position is too hindered because it's between NO2 and OH. So that cannot happen, and therefore that addition won't happen. Now we're left with the other ortho position right there and position para to it. Remember, para is 1, 4 right there. Now we end up in a situation where NO2 is favoring that position, but OH is favoring ortho and position para with respect to it. We know that OH is a stronger director because it's further to the right, and therefore OH wins. And therefore you end up adding the new group, the Br, to that position that's para to the OH, and the position that's ortho to the OH. Thank you very much for your time. If you enjoyed this presentation and you'd like to see more like this, please consider subscribing.